To find the exact value of our 6 different trig functions given this information, we're going to need to be able to go through and do a couple of things. We are given a right triangle. They've labeled one of the angles in our right triangle with the Greek letter theta, and they've given us the lengths of 2 of the sides. In order for us to find all 6 of the trigonometric functions, we're going to need to know the lengths of all 3 sides. We only know 2 right now. So we're going to need to use the Pythagorean theorem. In order for us to find the length of that missing side. In the Pythagorean theorem, the hypotenuse is always the longest side. It's the one across from the right angle. So with how this triangle is set up, the hypotenuse C is going to be this side right here. And then the 2 legs, the 2 sides that make up the right angle, those are A's and B's, and it doesn't matter which one we label which, as long as we get the hypotenuse labeled as C. The other 2 are A and B, and we can just write those in. It doesn't really matter. So for this problem, A is equal to 5, the way that I have my triangle labeled here. The hypotenuse is 13, and the side I am missing is B in my Pythagorean theorem. So if I plug those values in, we'd have 5 squared plus b squared is equal to 13 squared. And we would want to solve algebraically from there to determine what b is equal to. Algebraically, when we solve, we do end up taking the square root of both sides of an equation, which means we should include algebraically a plus or minus. If this were just an algebraic problem and we're not related to a triangle at all, the answer would be plus or minus 12, but b is the length of the side of this triangle, and we can't have negative side length. So we're just going to use a positive 12 for the length of that side. Once we know the side lengths of all 3 of the sides, then we can use SOHCAHTOA and some reciprocals to find the 6 trigonometric functions. I'm going to go in and I'm going to label this triangle with the hypotenuse and the opposite and the adjacent sides. So across from the right angle is always the hypotenuse, so the hypotenuse has a length of 13 on this problem. And then our 2 legs, those are the opposite and adjacent sides, and you'll have to look at your angle theta to determine which is opposite and which is adjacent. Straight across from your angle theta, that's going to be your opposite side. And then the one that touches angle theta, the side that helps to make angle theta, that's your adjacent side. And then from there, we would just want to go through and use SOHCAHTOA to come up with sine, cosine, and tangent. And once we have those 3, then we need to remember our reciprocals. So using SOHCAHTOA, I know that the sine of our angle is opposite over hypotenuse, which would be the fraction 5/13. Cosine, that is the ka part of SOHCAHTOA, so cosine is adjacent over hypotenuse. And then the tangent of our angle is opposite over adjacent. So using SOHCAHTOA, we can come up with our 3 main trigonometric values, and then from there we would want to reciprocate. So the reciprocal of sine is cosecant, so just need to flip that fraction over. The reciprocal of cosine is secant, so just flipping over our cosine fraction, we get secant, and the reciprocal of cotangent is tangent. They're each other's reciprocals in each one of these cases, and that gives us our exact values for the 6 trigonometric functions.